6 components. No electrician, no permit, no power company involved. I know how that sounds. I said the same thing the first time I saw it. But stay with me for the next few minutes, because what I'm about to show you is not a theory. It is not a claim I found on a forum at midnight. It is a documented method, backed by patents in the public domain, used in modified form by researchers as far back as 1920. And it works. My name is Dr. Elena Ward. I am an independent energy researcher, and for the last 8 years, I have been doing exactly one thing: tracking what was removed from the standard electrical engineering curriculum. Not what got forgotten, what got removed. There is a difference. Things get forgotten by accident. Things get removed on purpose. If this is the first time you are on this channel, subscribe before we go any further. I release suppressed methods every week, and most people miss them because they never hit the notification bell. Now, let me start with how I actually found this. I was not looking for a bill reduction method. Not at first. In the summer of 2021, I was deep in a completely separate investigation, tracing the commercial history of capacitor storage in low-voltage residential systems. I had been working through a collection of declassified patent filings from the 1940s and 1950s, most of them flagged as commercially inactive. That phrase always catches my attention. Commercially inactive does not mean scientifically invalid. It means someone decided it should not be on the market. One filing stopped me cold. The document was from 1947, and the inventor had developed a circuit he called a passive voltage compensation system. 6 components: copper, zinc, a capacitor, a resistor, a ground stake, and an output node. The circuit was designed to harvest the differential voltage between a grounded copper surface and a secondary zinc plate buried at a different depth in residential soil. The principle behind it was not new. Volta described the galvanic cell in 1800. What was new was the application. This man was not trying to power a city. He was not filing a grand invention to replace the national grid. He was trying to show that a standard home already sat on a measurable voltage differential, and that differential could be intercepted and used. You do not need to generate electricity you are not making. You need to intercept what is already moving. 8 pages of dense technical notation, 3 hand-drawn circuit diagrams, and a margin note that said, tested, confirmed, June 1947, Salt Lake City. Salt Lake City. I had seen that location before. The Moray case is the one that kept me up the longest. Thomas Henry Moray was a Salt Lake City researcher who, in the 1930s, claimed to have built a device that harvested ambient energy from the surrounding environment. Not solar, not wind. He called it radiant energy, what he described as a sea of electromagnetic potential surrounding all matter. His demonstrations were witnessed by multiple engineers and scientists over a period of years. The device reportedly powered a 35-watt bulb from a completely isolated setup. No grid connection, no visible fuel source. Witnesses signed affidavits. I found a photocopy of a Salt Lake City police report, filed in 1931. 2 lines, shots fired, residence of T.H. Moray, researcher, no arrests, no follow-up. 2 lines and a case number that went nowhere. That was not a filing error, that was a decision. Moray died in 1974. The official cause was age-related illness. The circumstances of his research, the harassment, the incidents at his laboratory, the loss of funding sources one by one, those circumstances remain disputed. I present the documented record, not a conclusion. What I can tell you is that the 1947 patent filing I found was citing Moray's earlier work directly, by name. And that by 1952, that patent had been reclassified as commercially inactive and removed from the searchable public index, though the physical filing still exists at the National Archive. I have a copy of it in a folder I've carried around for 4 years. I want to be careful here. I'm not going to draw a line between Moray's story and the burial of this patent, not without documented evidence of a connection. What I will say is that both events happened in the same city, within 15 years of each other, and both involved the same underlying principle. If you want the complete Moray file, subscribe now and turn on notifications. I am covering it in depth in the next video, and it is one of the most documented suppression cases I have found in 8 years of research. You do not want to miss it. Now, let me show you the 6 components, Because here is what matters. The patent may have been buried, the principle is not. Differential ground voltage, the fact that two dissimilar metals buried at different depths in soil will generate a measurable electrochemical voltage. That is not a secret. That is standard electrochemistry. That is in every first-year chemistry text going back 100 years. Volta documented it. Danielle refined it. The principle is called a galvanic cell. What they never did was connect that principle to your power bill and hand it to you as a practical tool. Here is what you need. Component 1. A copper plate or a copper wire coil with at least 30 centimeters of exposed surface area. Copper is your positive terminal. It is the collector. It has a higher reduction potential than zinc, which means in a soil environment, electrons will tend to accumulate on the copper surface. That is your voltage source. Component 2. A zinc plate or a galvanized metal stake, also with at least 30 centimeters of exposed surface. This is your negative terminal. High zinc oxidizes more readily than copper. In the presence of soil moisture and mineral content acting as an electrolyte, a charge differential develops between the two metals. The same fundamental mechanism as the battery in your smoke detector. Except the electrolyte is not sulfuric acid in a sealed case. It is the ground under your house. Component 3. A capacitor. Minimum 1,000 microfarads, rated for low voltage DC. This is your buffer. Ground voltage is not perfectly stable. It fluctuates with soil moisture content, temperature shifts, seasonal mineral changes, proximity to other electrical systems. The capacitor smooths those fluctuations into a consistent, usable output. Without the capacitor, you get noise. With the capacitor, you get a clean DC signal. Adbrin, this is a component that costs under $1 at any electronics supplier. Component 4, a resistor. 10 kiloohms is the standard starting value for most residential soil conditions. The resistor sits in series between your copper positive terminal and the capacitor. Its job is to slow the charge rate. This protects the capacitor from current spikes when soil conditions shift rapidly, such as after heavy rain. It also extends the lifespan of every other component in the circuit. Do not skip it. It costs less than a cent. Component 5. The ground stake. A copper-coated steel rod, minimum 40 centimeters long, driven vertically into moist soil at least 30 centimeters away from your plate installation. This provides your reference ground connection and stabilizes the circuit against ambient electrical interference from nearby structures. Deeper is better. In most residential soils, 40 to 60 centimeters gives you a stable ground reference. Clay-heavy soils and mineral-rich soils perform measurably better than sandy or heavily compacted soils. Component 6. The output node. A low-draw LED indicator, a soil sensor module, a small USB charging circuit rated for input voltages as low as 1.2 volts, or any device that draws under 10 milliamps at low voltage. This is your load. What this circuit powers is not your refrigerator. I want to be clear about that. What this circuit powers is the low-draw infrastructure of your home, pathway lighting, garden sensors, outdoor cameras on low-power standby, emergency device charging stations. Here is the number that matters. 3 of these setups run in parallel in your yard, with depth variation between each pair of plates, produce between 1.5 and 3 volts of sustained DC at low amperage under normal residential soil conditions. In moist, clay-rich soil, output can exceed 3.5 volts across a parallel array. That is enough to run every outdoor sensor, motion indicator, and pathway light on your property indefinitely, without a single watt from the grid, without a single dollar added to your electric bill for those devices. It does not sound like much. I know that. Here's what it is. It is a start. And it is a start they never wanted you to make. Share this video with one person who pays too much for electricity right now. They will thank you, I promise. Let me show you something in the books. I own 2 editions of the same electrical engineering textbook, the 1962 edition and the 1978 edition. Same title, same publisher, same listed author. I have them both. I have looked at them side by side more times than I can count. Chapter 7. In the 1962 edition covers resonant frequency transmission and passive ground differential harvesting. 12 full pages. Detailed circuit diagrams, worked equations, soil conductivity tables, organized by region and mineral content. It is written as a practical implementation guide, not as theoretical history. It assumes the reader is going to build something. In the 1978 edition, that chapter does not exist. The chapters around it are renumbered. The content is not condensed or relocated. It is simply absent. No editorial note, no revision log, no acknowledgement in the preface that material was removed. Just renumbered chapters and a 16-year gap where the practical application guide used to be. I checked the copyright page. Same publisher, same original author, same stated edition lineage. I have now found 6 textbooks with this pattern. Different publishers, different authors, different institutions. Same window of removal between 1971 and 1982. The specific content that disappeared in every case was the practical residential application of ground differential and low-frequency resonant harvesting. The theoretical framework stayed. The build instructions left. I am not going to tell you there was a coordinated editorial campaign. That would require evidence I do not have. And what I can tell you is that the pattern exists across 6 independent publications from 6 independent publishers within an 11-year window, and patterns do not lie. Now let me walk you through the actual build, step by step. Step 1. Gather your components. Copper plate or coil, zinc plate, or galvanized stake, a 1,000 microfarad capacitor rated for at least 5 volts DC, a 10 kilo ohm resistor, a copper-coated ground rod, and your output device. Total sourcing costs should be between $4 and $8 from any hardware or electronic supplier. You do not need specialty parts. You do not need to order anything unusual. Step 2. Wire the positive leg. Connect your copper plate to the positive terminal of the capacitor. Place the 10 kilo ohm resistor in series between the copper plate and the capacitor positive leg. Solder or use secure crimp connections. Loose connections in ground voltage circuits will cause output instability. Step 3. Wire the negative leg. Connect your zinc plate directly to the negative terminal of the capacitor. No resistor on this leg. The zinc is your reference low potential terminal and draws no protection component. Step 4. Install the plates. Drive the copper plate into moist soil to a depth of approximately 20 centimeters. Drive the zinc plate at least 30 centimeters of horizontal distance away from the copper to a depth of approximately 40 centimeters. The depth differential between the 2 plates increases the electrochemical gradient and measurably improves output voltage. Do not install them at the same depth. Step 5. Install the ground stake. And drive your copper-coated ground rod into soil at least 30 centimeters from either plate to a minimum depth of 50 centimeters. Connect the bottom terminal of the capacitor negative leg to this stake with a separate wire. This stabilizes the reference voltage against external interference. Step 6. Connect your output node. Attach your LED or output module across the capacitor terminals, positive to positive, negative to negative. You will see between 0.6 and 1.8 volts on initial contact with dry soil. In moist soil, the output typically rises to between 1.2 and 2.4 volts within the first several minutes as the galvanic reaction stabilizes. If your initial reading is below 0.4 volts, add a controlled amount of water directly around the plate area. This accelerates the early galvanic reaction. After the initial stabilization period, natural groundwater sustains the reaction in most temperate and humid climates without further intervention. A few things I want you to keep in mind. Sandy, dry or heavily compacted soils produce lower baseline output. If you're in an arid region, the addition of a small amount of diluted electrolyte solution, 1 tablespoon of sodium chloride dissolved in a liter of water, applied to the soil around the plates once a week, significantly increases and stabilizes output. This is documented in the agricultural ground battery literature going back to the 1920s. It is not a trick. It is soil chemistry. Do not install the plates under or near concrete foundations. If the alkalinity of concrete chemically interferes with the galvanic reaction and dramatically reduces output within weeks. Garden beds, lawn areas, and unpaved soil zones are ideal. Do not install near high-current underground cables. The electromagnetic field from high-draw underground wiring will create interference in your capacitor output. Standard residential telephone or low voltage landscape lighting cable causes no measurable interference. Here is something I do not hear anyone else say. Some of the methods on this channel probably will not scale to power a house. Not yet. Not with materials that cost $8 and tools every homeowner already has. But that is not why this matters. The suppression of these methods did not happen because they were useless. And it happened because even partial adoption at scale would erode the billing dependency that the power industry built its entire business model on. A household that generates 20% of its low-draw power off-grid is a household that pays 20% less. Multiply that by 100 million homes. That is not an inconvenience to the power industry. That is an existential threat to the metered billing model. That is why the textbook chapter was removed. That is why the patent was reclassified. That is why you are hearing about this from me in 2026 instead of from an engineering professor in 1978. Subscribe now and share this video. The next video goes deep into the Moray device, the full documented history of how atmospheric and ground harvesting was pushed out of mainstream science, and a second circuit build that extends this setup significantly. I have been working on that file for 3 months. It is the most complete suppression case I have documented on this channel. 6 components. No invoice from the grid for this part of your home. The knowledge was always there. Now you have it. I'm Dr. Elena Ward. This is Free Power Files. Everything they decided you should not know about free, clean electricity. No corporate filter, no subscription, just the documented record.